So, in the last lecture, we discussed about Galois field, that is G f2 to the power n field. Uh, but we have seen that we have a different sets and we have different operator, but none of the set and then none of the operator is going to satisfy all the properties to be called as a field. So, for that, in the last lecture, we have discussed about the new sets as well as the new operator. And it is also discussed in the last one that how GF2 to the power n field will be represented if it has to be represented into the computer system. Then for that we came into the conclusion that it is the polynomial through which it can be represented more easily. In that also we discussed about the polynomials, how it will be represented and bit words can be represented in the form of a polynomial, as well as the different operations. And in that operation we have discussed the modulus operation. Today, now in this lecture we are going to discuss about the addition operation, what is the addition identity, addition additive inverse, multiplication, what will be the multiplicative inverse, and so on. So, in case of addition operation, in case of if we consider that the GF2 to the power n field will be represented in the form of a polynomial. So, let us go with an example that if you have to do addition operation for two polynomials and the two polynomials are given as such, x to the power 5 plus x square plus x, and we have to do the addition operation with another polynomial, that is x to the power 3 plus x square plus 1, and it is defined in G of 2 to the power 8 field. Then what will be the value of this addition? We have seen that how the addition operation is being performed. Addition operation is a very simple operation in which what we do, of course, x to the power 5, x square and x are the three polynomial, three items in first polynomial, three items in the second polynomial. So, we have seen that it is an XOR operation which is being performed in the as the addition operation. So, XOR operation means if the polynomial is having same exponential value, that will be cancelled out, and after all we will have the remaining. So, this result will be equal to x to the power 5 plus. Now, in this x square is there and x square is there, and since this addition operation is a XOR operation, so x square and x square same value, so the resultant will be 0. So, we will cancel out these two and we will left with x3 and then x and then plus 1. So, addition operation is simple XOR operation in which we allow all the values of the first polynomial, all the values of the second polynomial, besides if the polynomial, both the polynomial is having same exponential value, that will cancel out each other. So, process is to keep the uncommon term and whatever common term is to be deleted. So, it is simply a XOR operation. Now, additive inverse. Now, as far as the additive inverse is concerned, additive inverse is actually zero polynomial. What is zero polynomial? Zero polynomial is a polynomial when it is added with any polynomial, the resultant with that polynomial. So, as you see, in case of addition, 0 is the identity element. Why it is identity element? Because any value, any integer value is added with 0, the resultant will be that integer value. So, that is why it is called the identity element. Similarly, in case of polynomial, 0 polynomial will be the identity polynomial. Because since why 0 polynomial? Because if you add the polynomial with itself, you will get the 0. If you add, suppose one polynomial is x4 plus x plus 1. If you add this polynomial with itself, the result will be 0. So, this is the 0 polynomial. इसका बज रहा है, बंद कर दो रिंगर ऑफ. So zero polynomial is the additive inverse. With what is zero polynomial? With coefficient set to 0. So it means that if we have to take the additive inverse of any polynomial, the same polynomial will be the additive inverse, because if a plus a is going to give the result 0, it means this a is inverse of a, because this 0 is the identity element. Now additive inverse. The additive inverse of a polynomial is polynomial itself. Actually, it was not additive inverse, it is the additive identity. The additive inverse of a polynomial is a polynomial itself. This means subtraction operation is same as addition operation. Why it is so? Because if it is a plus minus a, if it is equal to 0, so it means whether we put plus or if we write it like this, a minus a, this is also equal to 0. So if a plus any element is equal to 0 and a minus same element is equal to 0, it means subtraction operation is similar as addition operation. Now the multiplication. How multiplication is being done in the polynomial. If we have two polynomials and we have to multiply, then what will be the result and how it will be done? Multiplication. Suppose we have to do the multiplication of x to the power 5 plus x square plus x, and have to do the multiplication with x to the power 7 plus x to the power 4 plus x to the power 3 plus x square plus x in g of 2 to the power 8. So what will be the how the multiplication is being done? So जैसे पहले आप normal multiplication करते हैं, first we will take x5 and multiply with all the elements of the second one. Then we take this and then multiply with all the elements. Then we'll take this and multiply with all elements. So what will be the result? x5 multiplied by x7, it will be x to the power 12 plus x to the power 9 plus x to the power 8 plus x to the power 7 plus x to the power 6. x5 multiplied by x7, x12, x5 multiplied by x4, x9, x to the power 5 multiplied by x3, x8, x7 and x6. Then plus Now we will take x square and multiply with all the elements. So x to the power 9 plus x to the power 5 plus x to the power 4 plus x cube. Then we multiply x with all the elements, x to the power 8 plus x to the power 5 plus x to the power 4 plus x to the power 3 plus x square. So अभी अभी हमने एडिशन ऑपरेशन पढ़ा है, एडिटिव प्रॉपर्टी पढ़ी है. सो दोज हु आर हैविंग द सेम coefficient, that will be reduced to 0. Here we find that x8 is there, x8 is there. It is going to reduce as 0. X to the power 9, x to the power 9, reduced to 0. X to the power 4 and x to the power 4, reduced to 0. X to the power 5 and x to the power 5, reduced to 0. X to the power 3 and x to the power 3, reduced to 0. So we will left with x12 plus x7 plus x6 plus x square. x12, x7, let us check one more time. X to the power 12, x to the power 9, x to the power 8, x to the power 7 and x to the power 6. Then x to the power 9, x to the power 9, then x to the power 6 होगा ये ना. This is x to the power 6. Then x to the power 4. No, it will be 5. 6. X square multiplied by x7, x9 हो गया. ये 1 हो गया. X square multiplied by x to the power 9. 9 के बाद 6, 6 के बाद x to the power 5 भी होगा. x6, x4, x5, x4 and x3. और इसमें क्या होगा? Then x multiplied by x to the power 8, x to the power 5, x to the power 4, x to the power 3 and x2. This is the third one. So x5 I have cancelled it out. So x6 will also cancel out. X6 will be cancel out each other. So we will not have x6. So the result will be x to the power 12 plus x to the power 7. Now since the exponential value is 12 and we are restricted with g 2 to the power 8. In gf2 to the power 8, the maximum coefficient exponential value will be n minus 1. It means x to the power 7 से ज़्यादा इसमें नहीं होना चाहिए. So what we will do? We will reduce it with the modulus value. Suppose the modulus value with this multiplication is given, the irreducible polynomial is, मान लीजिए दिया हुआ है, irreducible polynomial is, suppose it is given x to the power 8 plus x to the power 4 plus x to the power 3 plus x plus 1. So it means whatever we are getting in the form of a result, it has to be reduced by irreducible polynomial whose mod value is x to the power 8, x to the power 4, x to the power 3 and x. So we have to find out the remainder. So how we will be getting the remainder, and for that we will doing simple division process to get the remainder. How we will doing the obtaining the remainder? X to the power 8 plus x to the power 4, because this is the mod value. And we have to reduce what? X to the power 12 plus x to the power 7 plus x square. So if I take it x to the power 4 times, so what will happen? It will have x to the power 12 plus x to the power 8, x to the power 7, x to the power 5 and x to the power 4. We know subtraction and the addition operation is same. So what will happen? X7 will cancel out each other, x12 will cancel out each other. So we will left with x to the power 8 plus x to the power 5 plus x to the power 4 plus x square. So this will go one more time. So plus 1. So it will be x to the power 8 plus x to the power 4, because the remainder should come less than that. If you take suppose we want 3 is the mod value and 84 is the, suppose the value 84, we have to find out the mod value. So 3 6 2 24 24 and the result is 0. It means the remainder is 0. If it is 81, if it is 82 suppose, then 3 2s are 6, so it will have 22, 3 7s are 21, 21 and the result will be 1. So ultimately this value should come less than that. So हम तब तक डिवाइड करते रहते हैं जब तक रिमाइंडर की वैल्यू उससे कम नहीं आ जाती डिविडेंड्स. So same thing we are doing here, plus x to the power 3 plus x plus 1. This will cancel out, x4 will cancel out. So we will left with x5 plus x3 plus x square plus x plus 1. So after doing this multiplication, the result was this, but this result was more than, the exponential value is more than 8, 7. So what we have to do, we have to reduce it with the mod value, and suppose the mod value is given this one. अगर mod value कुछ और होगी तो result हमारा कुछ और आएगा. Suppose this mod value is given this, so ultimately the final result of doing the multiplication will be x to the power 5 plus x to the power 3 plus x square plus x plus 1. This is how the multiplication is being done. अगर irreducible polynomial नहीं दिया, then you have to write the same value. But this is incorrect. Now, what is multiplicative identity and how to find out multiplicative inverse? Identity. Multiplicative identity, multiplication में identity is always 1. तो अगर GF 2 to the power 8 है और 8 बिट के फॉर्म में रिप्रेजेंट करना है तो आइडेंटिटी की वैल्यू 0 0 0 0 and 0 0 0 0 1. That will be the multiplicative identity. If multiplicative identity is there, then what will be the multiplicative inverse? So for obtaining the multiplicative inverse, we will adopt the same method which we used to adopt in the normal case, that is extended Euclidean algorithm. We apply extended Euclidean algorithm for obtaining the multiplicative inverse of a particular number out of the set. If you want to find out the multiplicative inverse, you apply extended Euclidean algorithm. So same way, if you have to find out the inverse of polynomial, you have to apply the extended Euclidean algorithm. So let us check with an example how we will find out the multiplicative inverse of a polynomial within a polynomial with certain mod value. For example, if you have to find inverse, multiplicative inverse of x square plus 1 mod, जहाँ mod value दी हुई है x to the power 4 plus x plus 1, x to the power 4 plus x plus 1 in g of 2 to the power 4. You have to find out the multiplicative inverse of x square. So for that we will apply the extended Euclidean algorithm. How? Here we write quotient, here we write R1, here we write R2. Then we try to find out the remainder, then T1, then T2, and then we try to find out T. So here R1 is the mod value x to the power 4 plus x plus 1. Here it is x square plus 1. T1 is equal to 0 and T2 is the initial value. So with the help of these two, we have to find out R and then we have to find out T. I am not going to repeat the extended Euclidean algorithm. So how many times it will go? X square plus 1. So let us do some rough work. X square plus 1 and x to the power 4 plus x plus 1. So what will happen if we do x square? So x4 plus x square. So we will left with x square plus x plus 1. So it will go one more time. So it will be x square plus 1. So we will left with x. So it means quotient will be x square plus 1 and the remainder value will be x. Now, if T1 is equal to 0 and T2 is equal to 1, it is assumed by it is given by the extended Euclidean algorithm itself. Then what will be the value of T? Now you know the value of T is equal to T1 minus Q into T2. So T is equal to T1. So T will be equal to 0 minus Q की value कितनी है? X square plus 1 and it will be multiplied by 1. So it means this value will be equal to x square plus 1. Here minus is there, so you can say that it is minus x square plus 1. But you know addition operation is similar as the subtraction operation. So minus x square plus 1 is equal to x square plus 1. So this value of T will become x square plus. Now what will happen? R2 will become R1 in the next step. R will become R2 x. T2 will become T1 1 and T will become T2, that is x square plus 1. So how many times it will go? X time. X square, so remainder will be 1. And what will be the value of T? T will be equal to T1 minus Q, that is x, into T2, that is x square plus 1. T1 की value यहाँ पे 1 है. So it will be 1 plus x cube plus x. So the value will be x cube plus x plus 1. Now again this will become x and this will become 1. This will become x square plus 1. This will become x cube plus x plus 1. And then it will go x time. The remainder will be equal to 0. Then what will be the value of T? T will be equal to x square plus 1 plus x into x cube plus x plus 1, and that will be equal to x square plus 1 plus x to the power 4 plus x square plus x. X square going to cancel out, so we will left with x to the power 4 plus x plus 1. So the T will be equal to x to the power 4 plus x plus 1. So what will happen? Next time it will be 1, it will be 0, it will be x cube plus x plus 1, and T is x to the power 4 plus x plus 1. Now extended Euclidean algorithm says when this R1 becomes 1, whatever is the value of T1, that will be the multiplicative inverse. So the value of T1 is x cube plus x plus 1. It means x cube plus x plus 1 is the inverse of x square plus 1. Since R1 is equal to 1 and T1 is equal to x cube plus x plus 1. So this will be whatever at the time when R1 becomes 1, whatever is the T1, that value is the inverse. So you can say that how I will consider that this value is correct, this value will be fault. तो क्या होता है कि मल्टीप्लिकेटिव इनवर्स के केस में a into a inverse is always equal to 1. So if you want to check, you can check it. कैसे? x square plus 1 मैंने कहा कि x square plus 1 का इनवर्स है x cube plus x plus 1. So if we multiply these two, we should get 1. If it is so, then only you can say that x cube is x cube plus x plus 1 is a inverse multiplicative inverse of x square plus 1. So let us check. Let us multiply x square plus 1 multiplied by x cube plus x plus 1, considering the mod value is x4 plus x plus 1. So let us find what is the value. X to the power 5 plus x cube plus x square plus x cube plus x plus 1. This will cancel out. So we will left with x to the power 5 plus x square plus x plus 1. Now this is not 1. Now if this is not 1, how we can say this value should come, but we have to take the mod. Mod of what? X to the power 4 plus x plus 1. So let us take the mod. So how mod will be taken? X to the power 4 plus x plus 1, x to the power 5 plus x square plus x plus 1. So let us go with 1 x time. So x to the power 5 plus x square plus x. This cancel out each other and you will left with. So remainder is 1. So if the remainder is 1, it means this is inverse of this one, or the inverse of this is this one. So that is how the multiplicative inverse is being found out. Let us go with another example. Find inverse of x to the power 5. Modulus value is given, mod x to the power 8 plus x to the power 4 plus x to the power 3 plus x plus 1 in GF 2 to the power 8. If mod value is not given, then you are unable to find out the multiplicative inverse. So if it is so, then we will do the same process. T1, T2, T, R1, R2, Q. X to the power 8 plus x to the power 4 plus x cube plus x plus 1, x to the power 5. It will go x to the power 3 times. If it will go x to the power 3 times, this will cancel out and you will left with what will be the R, x to the power 4 plus x to the power 3 plus x plus 1. T1 की इनिशियल वैल्यू 0 है, इसकी वैल्यू 1 है, तो t की वैल्यू क्या होगी? T1 यानी 0 माइनस x to the power 3 into 1, यानी ये हो जाएगी वैल्यू x to the power 3. Then next time here it will be x to the power 5, here x to the power 4 plus x cube plus x plus 1, here 1, here x cube. So let us find out R. So when we divide, it will go x time, so that x5 will be cancelled out and you will left with x to the power 4 plus x square plus x. X to the power 4 plus x square plus x. कैसे आएगा देख लीजिए. So it will be x to the power 5 plus x to the power 4 plus x square plus x. So this will cancel out. We will left with x to the power 4 plus x square plus x. That is what has been written. What will be the value of t? 1 minus x. 1 minus x. T will be equal to T1 minus Q into T2. So I have done something wrong. Let us check whether this is correct or not. X to the power 4 plus x cube plus x plus 1, x to the power 5 will go x times, so x to the power 5 plus x to the power 4 plus x square plus x. So we will left with x to the power 4 plus x square plus x. Now this is still above that, so it will go one more time. If it will go one more time, so it will be, you will have x to the power 4 plus x cube plus x plus 1 plus 1. So this will cancel out and you will left, x will cancel out, x cube plus x square plus 1. Since mod value is x to the power 4, so this r value cannot be x to the power 4. It has to be reduced. So it will be x cube plus x square plus 1. So this will be x plus 1. So this will be, t will be equal to T1 minus Q into T2. T1 is equal to 1 plus Q is x plus 1 into x3. So it will be 1 plus x to the power 4 plus x cube. So this will be equal to x to the power 4 plus x cube plus 1. So the next time it will be x to the power 4 plus x to the power 3 plus x plus 1, and this will be x cube plus x square plus 1. This will be x to the power 3 and this will be x to the power 4 plus x to the power 3 plus 1. So let us check this one, x square plus x cube plus x square plus 1, x to the power 4 plus x to the power 3 plus x plus 1. So x time, so it will be x to the power 4 plus x cube plus x. So this will cancel out each other. So you are left with 1. So remainder will be 1 and quotient will be x. And so the value of t will be x cube plus x to the power 4 plus x to the power 3 plus 1 into the quotient x. So this will be equal to x to the power 3 plus x to the power 5 plus x to the power 4 plus x. So the result will be here x to the power 5 plus x to the power 4 plus x to the power 3 plus x. So the next time x cube plus x square plus 1, and here it will be 1, x to the power 4 plus x to the power 3 plus 1, and x to the power 5 plus x to the power 4 plus x cube plus x. So it will go how many times? It will go x to the power 3 plus x square plus 1, so that the resultant remainder will be 0. And we will calculate some value over here. T value calculate कर लेंगे. कैसे calculate करेंगे? This this plus multiplied by this into this. So, we will be getting certain value, suppose it is t. We are not at all concerned what will be that value, because why we are not concerned, here it is 1, it is 0, here it will be x to the power 5 plus x to the power 4 plus x to the power 3 plus x, and here it will be t. It does not matter whatever is the value of t. Why? Because R1 is 1, so whatever is the value of T1, that is x to the power 5 plus x to the power 4 plus x cube plus x, that is the inverse of x to the power 5. If you want to test it, you multiply this by this and take the mod, you will be getting 1. So that is how the multiplicative inverse of the polynomial is being